Hello there, my name's Gary Sims and this is Gary Explains. Now, no matter what processor comes out next, whether that's from Apple, whether it's from a design that ARM make or one of ARM's partners like Qualcomm or MediaTek, I can guarantee your smartphone won't be fast enough. It won't be fast enough, and neither will next year's one or the one the year after that, and so on. Now you might be saying, Gary, that is an absolutely crazy statement to make. Well, if you don't believe me, please let me explain. Okay, so let's start looking at the reasons why your smartphone will never be fast enough. And to do that, we're going to be looking at the Jevons coal question. So this is something that was developed back in the age when coal was used, Victorian times in Britain. It was the main source of fuel, and there was some interesting thoughts about this. So the coal question is a book written by William Stanley Jevons, an inquiry concerning the progress of the nation and the probable exhaustion of our coal mines. So it was written in 1865, and it was looking at the exploration of a finite resource. So obviously this is something we still talk about today in terms of different power. You know, we've got oil and we've got coal, and then we've got other forms of energy, nuclear, wind, solar, and so on. And these are the things people talk about. Now, I'm not going to talk about the implications for economy in terms of energy supply for a nation. I'm not going to talk about that. That's what other people who are experts in that area may talk about. But from this paper that was written in 1864, we get this thing called the Jevons Paradox. And here's just a picture of that book, The Coal Question, by W. Stanley Jevons, 1865. So, Jevons Paradox is, as quoted by him then in The Relevance of Coal, "It is wholly a confusion of ideas to suppose that the economical use of fuel is equivalent to a diminished consumption. The very contrary is the truth. Every improvement of the engine," of course he's talking about the steam engine there, "when effected, does but accelerate anew the consumption of coal." So in other words, when there is more efficient use of the coal, when you can mine it more efficiently, when you can use it more efficiently in the steam engine, it actually leads to greater consumption, not less consumption. And we can convert that into smartphones. It's wholly a confusion of ideas to suppose that more efficient processors lead to the need for less performance. The very contrary is the truth. Every improvement of the processor does but accelerate anew the demand for greater performance. So the thing to remember about smartphones is that when ARM brings out a new CPU or GPU, it's generally more efficient than the generation before, and not necessarily just because of the process node. There's actually internal changes inside what's called the microarchitecture, the way it's designed to make it more efficient. Now, that efficiency gain can be translated into one of two things. Either efficiency, so you do the same task in the same amount of time, the same performance, but you do it more efficiently, and therefore we get better battery life. Or you can use that extra efficiency to give you the same battery life, but do it quicker because you're using the new performance. So the Jevons paradox occurs when the technological process increases the efficiency with which a resource is used, in this case the CPU or GPU, reducing the amount necessary for any one use, so you don't need to use as much energy to achieve the same task, but the falling cost of use increases its demand. So of course smartphones are getting more and more popular. We're not seeing a decline in popularity. More and more people are using them, and we're using them more and more often. Many people assume that efficiency gains will lower resource consumption, ignoring the possibility of the paradox of this effect arising. So what does this mean for us? So better efficiency and falling costs means increased demand. Efficiency is the energy used, and therefore that translates directly to battery life. Increased demand is a need for greater performance. So when we have access to more performance, we find ways to utilize that performance. And this is the key thing here. This is why your smartphone will never be fast enough. because the moment we get more performance, we find ways to use that performance. Now, there's a caveat to that, which I'm going to talk about more later, which is about badly written software. But let's ignore that for the moment, okay? So when we have access to greater performance, we find new ways to use our smartphones, new ways to do things, new things we can process, new things that we can add, new features we can do, new types of software, just a whole new experience because we've now got greater performance than we had before. Now, many people in the comments, when ARM release a new CPU, or when I do a benchmark, or I've done some kind of testing on some kind of device, they assume that the efficiency gains will actually mean that performance demands are lower. And so you get these comments like, laugh out loud, why do you need a faster CPU just to scroll through social media? These are not word for word quotes, but I've had, dozens, if not, hundreds of quotes like this over the years of people saying things. Phones are fast enough as it is. They should concentrate more on efficiency. That's a classic one because, of course, as I've just said, it is the efficiency that's led to the increase in performance. We don't need faster phones, we need bigger batteries. I don't know how many times I've read comments like these. You guys are raving about a new processor so you can just play solitaire or Angry Birds, or use Instagram, or whatever it is that someone wants to quote about. They're just saying that all we're doing is using our phones for just scrolling basically, and not for anything else. So who's right? Is it the people who are saying we don't need faster phones, or is it the people saying we do need faster phones? This is the interesting question. So here is a graph I've put together. It's based on some data released by Antutu. I've not put any numbers on it because it's just to give us a general idea of direction. We could have built this graph using other benchmarks, but I think we'll find the same general trend across. So we basically got the Snapdragon 810 from 2015 down here, and then we can see this is performance. This is CPU and GPU performance together, because that's what Antutu does, right up here to 2023, and this is a 500% improvement in 8 years. Okay, so today's smartphones are 500% faster in terms of CPU and GPU than a phone in 2015. Now, did we need that performance? What was the Snapdragon 810 or the Snapdragon 821 good enough, and we should have stopped in just concentrating on efficiency? Well, that is a very interesting question. But one thing to note is that battery sizes didn't go up by 500%. So the OnePlus 3T, which is a 2016 phone, had a 3,400 milliamp hour battery, and that was with a 5.5-inch display. Why is that important? For two reasons. One, of course, the display also uses a lot of battery, as does the radios, so 3G, 4G, 5G, Wi-Fi, Bluetooth. But also the form factor changes as the phone gets bigger, which they did over these last 5 years or so. Then they can put bigger batteries in. So they're there just because it's physically a bigger device. There's more room for a battery. Now, the Samsung Galaxy S23, the 2023 phone, the small one, not the Plus or the Ultra or whatever, has a 3,900 milliamp hour battery, and that's got a 6.1-inch display. So we've seen an increase in battery size, which I think is mainly due to the fact that the devices are physically bigger, but in no way is it 500% bigger than it was in 2016. But yet we've had this incredible gain in performance. So what can we do with phones today that we couldn't do 5, 8, 10 years ago? Well, first of all, of course, the overall speed, fluidity, smoothness, launch times, how quickly things happen has just improved, obviously by 500%. Depends on the software, depends on what particular thing that is you're doing. But I do remember with frustration seeing people who bought cheaper phones 10 years ago, 8 years ago, 5 years ago, and they would literally be tapping several times on the screen just to get it to respond because it was just overwhelmed in doing what it was doing. And that's because what happens when you bought a cheaper phone then, because it was, the processors were nowhere near as fast. So the cheaper, that was a flagship devices I was showing on that previous slide. So cheaper than that were even slower. Now, of course, we are able now to do things like render more complex web pages. Apps themselves can be more sophisticated. So we've certainly seen an increase in complexity, whether that's from the web or from an app itself that you didn't have 5 years ago, 8 years ago. That certainly has happened, and that's been allowed because of the performance gains. And then, of course, there's been big changes in gaming. Today we're talking about games like Apex Legends and Fortnite and Genshin Impact. And the top game of 2016 was Clash Royale. So we're talking about a 2D game just moving sprites around the screen, which is something we've been doing since, the 1980s with home computer games and and so that wasn't something. It was just a bit more colourful and a bit more impressive on a nice crisp resolution display. But now we're up into high fidelity gaming, 3D gaming that you couldn't have done before. And of course we've got advanced computational photography. We've made huge strides in that over the last few years, and the additional stuff of machine learning and all that are just increasing that even more. In fact, I'll talk about that in a second, but in fact the ML stuff that you get on the device, I'm particularly thinking about Google's Pixel devices, the ML stuff that we're doing on device is something that couldn't have been done before, and that's also for photo, that's also for stuff like transcription. Now some of this stuff is still done in the cloud, but this will all come down to the device. That's where the trend is going, because it's cheaper to do it on the device, so that the companies running these things don't need to have $1 million worth of servers up in the cloud to actually cope with all this stuff. 8K and 4K video encode, decode, advanced video editing. Again, these are things that have come along recently because there wasn't the processing power also in the video processing stuff. So CPU, GPU, video processing, wherever you want to put the processing power, we've got more of it now than we had before. And of course there are a whole bunch of other areas. Emulation, I'm thinking if you're emulating something, the greater performance you've got, the greater ability you have to emulate that in the smoothest possible way. VR, AR, ray tracing, these are all different subjects, but they're all things that we're doing today that were not possible in the past. And of course there have been some classic quotes over the years by people who thought that whatever resource it is that we had, whether that's processing power, memory, storage, graphics, whatever it was, that we've reached a pinnacle. We don't need any more. And of course, over the years, some of these even become comical. So I think there is a world market for maybe 5 computers, said Thomas Watson, the president of IBM, in 1943. Now, yes, if you were buying a computer that took up the whole floor of a building and cost millions and millions, then yeah, there probably were only a market for 5 computers. He didn't realize, of course, where technology would go, how things would shrink down. And of course today we have supercomputers that are being sold that are just as big and they take up massive amount of space, but there's certainly more than 5 of them. They're being used absolutely everywhere. So he was just wrong, but you can't blame him. It was 1943 and this was the beginning of the computer era. So don't make a prognosis about something because you're probably going to be wrong. There is practically no chance communications space satellites will be used to provide better telephone, telegraphy, television or radio service inside the United States, the FCC commissioner in 1961. Today, of course, we've got satellites whizzing around the Earth giving us high-speed internet, let alone television and radio and telephone and all that kind of stuff. So, wildly wrong in that sense. There's no reason for any individual to have a computer in their home. Ken Olsen, the president of the company that I used to work for, Digital Equipment Corporation, 1977, again, talking about mini computers. They were big, size of a kind of a fridge or a double fridge, a bigger home appliance. There wasn't something you'd want to put in your home. Again, we've got the equivalent of that kind of computing power in our hands nowadays in these smartphones. And then the classic one, which Bill Gates actually does deny saying, but 640k ought to be enough for anybody. Bill Gates supposedly uttered this statement in defense of the IBM's PC 640k usable RAM limit in 1981. He says he didn't say that. But even so, the point is that anybody who says, oh, that's enough for anybody, it's not going to be enough because there are going to be new use cases. The IBM PC with 640k does not do what I'm doing here on my PC as I'm making this presentation with Adobe, Photoshop and video editing, and I've got the web, and I've got streaming, and I've got music, and I've got code development, and I've got games, and none of that would have happened on a 640k IBM PC. And who knows what we're going to be doing tomorrow? Who knows what the next era, the next shift is? Obviously, I think machine learning is going to be part of that, but it's going to be a change that means that machines that are older couldn't do the things that we do today. Now, this thing I've been talking mainly about smartphones. Of course, this does apply to desktops, laptops, servers. So you've got, gaming, for example. Every time a new game comes out, the requirements for that game are, people, wow, why do I need to have this PC to run that game? And that's a new requirement because you need the processing power to bring that level of realism, that level of graphics fidelity to the game. Laptops, the same. You want to do video editing, you want to do photo editing, you want to do things like that. You're going to make sure it's going to have enough enough oomph, enough performance to do it. Servers, the machine learning stuff, the stuff that's running ChatGPT, it need more and more and more. We need more CPU, GPU, maybe bespoke accelerators, but we're going to always need more. And there's other areas that you can look at that need these things. Self-driving cars, for example, or at least computers on board in a car. You're not going to be able to do that with an IBM PC with 640k of memory. Things have moved on. We need more performance. Now, I said earlier on we'd talk about the fact that when we get more performance, we do find a way to use that performance. Now, there is one negative side effect in software engineering, which is bloat. So Nicholas Wirth, the guy that invented Pascal and Ada and so on, said faster hardware can trigger the development of less efficient software. And so that's absolutely true. The hope is that progress in hardware will cure all software ills. However, a critical observer may observe that software manages to outgrow hardware in both size and sluggishness. And this is an absolute true point. That the fact that when we've got more hardware, software engineers do become lazy. And so rather than making sure that something is at its best, it's, don't worry, the processor's fast enough to handle that. Now, we'll talk more about this, but there is another paradox called the Downs-Thompson paradox, which talks about traffic. Increasing road capacity can make traffic congestion worse. Which is also the Lewis-Modridge position that says that as more roads are built, more traffic consequently fills those roads. So traffic expands to meet the available road space. So this is more on the side of bloat, not on the side of new features, not on the side of we can do more things that we couldn't do before, not on the side of things that we can do, the things that were not possible, were out of our reach, but in fact you just fill up that gap that they've made with just bloat. And that's a very bad thing. Now, I hate bloat. So as someone who worked as a software engineer for DEC, as I mentioned earlier on there, for over a decade, at a time when I was working in server software, 128 megabyte Unix server was top of the line. Okay, obviously that went up over the years, half a gigabyte, a gigabyte in a server. I mean, we were falling over ourselves. I mean, this stuff is 128 megabytes, was the top of the line server. And when we wrote our software, we had to write it accordingly. We had to write it so that it would actually fit into that system and run efficiently in that system. And so I hate bloat. I hate the fact today that I have to boot up a PC and it's got 16 gigs, 32 gigs of memory, and suddenly there's not enough. Windows or whatever OS you want to throw at it, how come I could run all this in 128 megabyte Unix server and now I need 16 gigs to do it? That's my question. So bloat, here's a quote from me that people, maybe they'll quote me in the future. I doubt it. But bloat is very rarely the fault of an individual programmer, but of the designer of the system. So what do I mean by that? If you give a programmer a job to do, write a function that will do this, or write a module of code that will do this. Your job is to do this part of the system. Okay, they'll do it, and they will generally do it fairly efficiently. They won't allocate loads of memory they don't need. They won't use up loads of disk space they won't need. They won't waste loops doing things in an efficient way. They'll find ways to go through whatever data structure is they've got to go through in the most efficient manner, rather than it just being bogged down in CPU time. They'll do that. Absolutely they will. That's their job, and that's what they'll do. But the problem is it's the actual system architect, the person who puts all those individual bits together. So Windows itself is not probably inefficient in any one part, or Linux in any one part. When I talk about Linux as a desktop with all the stuff that we can get with it, or Mac OS. But when you put them together and you run so many different background tasks, and you run so many different systems, you run so many different things, then you get to ask yourself the question, where is the efficiency? Who is the system designer? Who's the guy looking over all of it from above? Study after study shows that the very best designers produce structures that are faster, smaller, simpler, cleaner, and produced with less effort. The difference between the great and the average approach an order of magnitude. And of course, that's from Frederick Brooks, from The Mythical Man Month, a book that anybody who's interested in any kind of software engineering should absolutely read without any doubt whatsoever. So the point is that the difference in a great designer and an average designer is in an order of magnitudes. And I think sometimes when you look at some of these systems, we're missing great designers. not the individual coders. Coding is a thing, but designing system architecture is a different thing. Okay, rant over. But just off topic while we're talking about that, and I admit this is off topic, but I just threw this slide in here while I was making this. Generative AI is certainly going to help for programming, coding. So I need a function that will do X. Fine, here it is. And it just basically, because it's read all of Stack Overflow and tutorials all over the internet, it's kind of worked out what it needs to do. But at the moment, it has no ability to design systems. It certainly cannot design a system from a holistic point of view. It can do smaller stuff, but it can't do bigger stuff. And the question is, to design systems, do you need AGI? And I'm using the word AGI now because machine learning was really what's happening now. This generative AI is actually generative machine learning. But the term AI has been hijacked, and I use it as well because it's just entered into the normal speech now. But so AGI is artificial general intelligence. So something that, in quotes, approaching having some kind of consciousness, something that is aware, something can understand concepts. Of course, ChatGPT doesn't understand context. It just knows what token to output next. So to design systems, do you need AGI rather than machine learning? My suspicion is yes, you do. And so I don't think software engineers are going to go out of business anytime soon. That's my personal opinion, because coding and software engineering are technically two different things. Okay, so where are we? We don't know what is possible tomorrow because the tools needed haven't yet been invented. And one of those tools is processing power, and of course there are others. Okay, so there you have it, Jevons Paradox and why our smartphones will never be fast enough. There are things coming in the future that we can't even imagine at the moment because we don't have the processing power, the tools to even think about how to create these things. I'd love to hear what you think in the comments below. Okay, that's it. I'll see you in the next one.